Welcome. I'm going to be doing some problems from homework number 7. I'm doing 5 and then 15 through 23. I'm in a coffee shop right after a doctor's appointment, so bear with the background noise for me. I appreciate that. Here we go. A hacker is trying to guess someone's password. The password hacker knows somehow that the password is 11 characters long. Each character is either a lowercase a through z, an uppercase a through z, or a numerical number 0 to 9. Assume that hacker takes a random guess. What is the probability um, that he gets the password on the first try? So you have 11 characters, and each character could be one of the following things. It could be um, 10 digits, or 26 lowercase, or 26 uppercase. So that is, it would be 52, 62 different options for every single. So the number of different passwords is 62 raised to the 11th. So this is going to end up being 1 over 62 to the 11th, which is infinitesimally small. It says probably you have to enter your answer as a decimal or a fraction. I would try entering it in just like this, um, and see what happens. Um, if it's a fraction, it's gonna be like 0.000 da 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 da. So anyway, that is how that works. You have 62 11 times. There's 62 options for the first thing, 62 for the second thing, 62 for the third thing, all the way up to 62 for the 11th thing, 62 to the 11th. All right, hopefully that's helpful. And now our next one is number 14. A large population, 59% people have been vaccinated. If 3 people are randomly selected, what is the probability at least one is vaccinated? So I want to talk a little bit about what the possibilities are. If you have a total of 3 people, you have 0 people could be vaccinated, 1 person could be vaccinated, 2 people could be vaccinated, or 3 people could be vaccinated. If I'm looking at least one, that's this, this, and this. My choices are to figure out what these 3 things are and add them together, or to take this and subtract it from 1. Why 1? Because 1 is 100%, and that represents 100% of the options, minus the probability of 0 would be at least 1. And this little formula is really helpful because usually 0 people vaccinated is not too hard to, 0 people anything is not too hard to calculate. So I have 3 people. You know what the probability them at least 0 of them have been vaccinated. Well, if 59% have been vaccinated, that means that 41% have not. So probably the first one's not vaccinated is 41%. Probably the second one's not vaccinated is 41%. Probably the third one's not vaccinated is 41%. So this probability of none being vaccinated is the first one's not, the second one's not, and the third one's not. So we multiply those together. That gives me 41 to the third. And then whatever that is, I take 1 minus that answer. And that's going to be the answer that goes here because that's the probability that is this right here is the probability of this. These together equal 100% of the options. And I want these 3, so 1 minus that gives me what I have there. All right, moving right along. A certain virus infects one out of every 200 people. A test used to detect the virus is positive 90% of the time. If a person has the virus 8% and has the virus, and 8% of the time, if the person does not have the virus, if this 8% is called a false positive. Let A be the result that the person is infected, and B be the result that the person is positive. And then it gives us a really important hint here. It says make a table. Again, I apologize for any background noise here. So what we have here, what we're doing is I'm going to make a table, and this is what the test says. Test says positive, positive, and negative. And this is if you have the virus yes, and virus no. All right. All right. And this is going to be 100% here. All right, first of all, I'm going to put the number 200. We're working out of a number 200. You can work any number you want, but I find that, this makes it a little easier. It infects 1 out of 200, so 199 actually do not have the virus, right? Right. And the test used to detect the virus is positive 90% of the time if the person has the virus. So this is zero point 0.9 and this is zero point 0.1, right? So these guys are going to get false negatives. Like they actually have the virus, but they aren't going to get worked in. And 8% of the time if the person does not have the virus. So I have 199 people who do not have the virus, and I'm going to figure out what 8% of that is. So I'm going to go 199 times zero point 0.08, right? And 199 times zero point 0.08 is 15.92. All right. All right. So there's that. And then I'm going to subtract. This has to add up to 199. This whole line has to add up to 199. So I'm going to go 199 minus 15.92. And this is going to be 183.08. Right? Add these guys up. So 15.92 plus zero point 0.9, 16.82. And then um, zero point 0.1 plus 183.08. And this is 183.18. And notice if I add these two numbers together, um, let's do that. Um, if I add these two numbers together, this right here, oh, here we go. My goodness, struggle. Was 16.82. No. If I add this number with this number, I should get that number. That's what I was trying to say. Also, this number and this number should get that number. Good. Now it says find the probability A given B. The A represents the person is affected, so let's make sure we have this. This is the person has the virus. B is the event the person tests positive. All right. All right. So A given B. The probability of A given B. Since we're given B, we're only looking at this particular row right there. We know they tested positive. So we are looking at this probability of zero point 0.9. That's the probability they have the virus over all the people that tested positive. So that'd be zero point 0.9 divided by 16.82. So, and find the probability the person does not have the virus given they tested negative. So, given they tested negative, right here, and they do not have the virus. All right. So here's no. All right. So this is over that. So it's going to be really high, like 99. 83.08 divided by 83.18. So 0.999999995. Okay. So hopefully that is helpful to you. All right. 16. Of 4 cards are drawn from a standard deck. Give the answer as fractional out to this one. Probability that all cards are hearts. Well, first of all, we know from cards where there are 13 hearts, and then there are 13 diamonds, 13 clubs. That's not a very good club. And 13 spades. There we go. Probability of all the cards that we're drawing for. So the first one is a heart, 13 out of 52. Now, we're not trying with replacement. The second one is heart, 12 out of 51. The third one is a heart, 11 out of 50. The fourth one is a heart, 10 out of 49. So, right. This is how many hearts were in the deck. I took one out, now there's this many. I took another one out, now there's this many. I took another one out, now there's this many, right? Now there's another way we can do this, and it's called using the choose. There are 13 hearts. We're choosing 4 of them. There are 15 cards. We are choosing 52 cards. We're choosing 4 of them. So this and this will end up giving you the same exact probabilities. Find the probability that all the cards have face cards. So face cards are kings, queens, and jacks. So there's 12 total in there because there's one of each of the 3 suits. So again, I think the easiest way is to say, okay, the first one is a face card, there's 12. Then the second one is a face card, took one out. Then the third one is a face card. And then the last one is a face card, right? Find the probability that all cards are even. Consider jacks. Okay, so we're going to consider these guys, queens, to be even as well. So how many even cards are there? So let's write it out here. We got a 2, a 4, a 6, an 8, a 10, and a queen. 1, 2, 3, 4, 5, 6 times 4 suits. 24 out of 52. 24 out of 52. Then 23 out of 51. Then 22 out of 50, taking 1 out each time. 21 out of 49. There we go. So you do that message right there. That's problem number 16. Let's take a look at 17. All right. It says, in algebra classes, 8 students and 8 desks. For the sake of variety, students change their seating arrangements. How many days must pass before the class must repeat the seating arrangement? All right. So, well, we have 8 days and 8 seats. So if you think about again, this is just kind of 1, 2, 3, 4, 5, 6, 7, 8. I have 8 seats. The first person comes in, there's 8 different ways that he can pick that seat. Then the second person come in, the first person's already there, so the 7th person, why did he do that? Then 6, 5, 4, 3, 2, 1. So this is 8 factorial. Suppose the desks are now arranged of rows of 4. So now we have it looks like this. Right? All right, and they must put Larry, Mo, Curly, and Shep in the front seats. All right, so first of all, we have to put Larry, Mo, Curly, Shep up here. But notice that we can arrange these in all different ways. There's 4 factorial ways that we can arrange them, right? And so there are 4 factorial ways for the front seats. So 4 factorial is 4 times 3 times 2 times 1. So if I go on my calculator, 4, and then I can find the factorial number if I choose the math menu, go over to probability, and it's number 4, and that gives me 24. I can also type in 4 times 3 times 2 times 1, right? So there are 24 ways that we can put them. What's the probability that they're sitting in the front seats? Well, now remember, this is all the different ways we can do it, right? Whatever a factorial is, which if I do that on my calculator, do the math menu, go over to probability. It is. So the probability that we get all 4 in the front seats is the 24 different ways I can have them in the front seats, and then over all the different ways that we could seat people. All right. So if I do that to decimal places, it's 0.00059. So it's to 4 decimal places. Look like that. Okay. All right. All right. We want the probability of B given A. Right. It says that it's helpful to sketch a Venn diagram. I will do that for you, but I also want to sketch a table because I find tables to be really super helpful in these cases, right? So we have A or not A, and B or not B, and then our totals, right? I'm going to do these in percentages. So all of A is 48. Got that there. All of B is 42. These are percentages. They're out of 100. All right. So I'm just like putting the information where it goes. Probability B and A is 10. That means if I fill this table in, just like it's one of those magic squares from your youth, this is 38, has to add up. This is 32, has to add up. This is 52, has to add up. This is 20, this has to add up to 58. Notice these columns all add up to 100. Looking pretty good. B given A. Well, A is this row right here. We're given that. That means our whole world is just that. So now we're going to take B given A. B is here. Given has to just be an A. 10 out of 48. Right? And that's our answer. I really feel like those tables are super helpful. All right, let's do a Venn diagram. Same idea. All right, so here's A, here's B. There's 10 together here. Together. You have to work inside out in the Venn diagram. 48 total in A, so now this becomes 38 here. Okay. And then B is 42, so this would be 32 here. Right, there's our Venn diagram. And now it says B given A. So they want to find what's the probability that you're in B given you're in A. There's 10 out of all the people in A. And again, 10 out of 48. I really feel like the table is easier to see, but this is how you would do it with the Venn diagram. But there is a formula that's in your book, and it just says the probability of B given A is the probability of B and A divided by the probability of A. So if we just use the formula, B and A is here, that's 0.10 over the probability of A, that's 0.148, and that gives you the same thing here. All right, so that was number 18. And checking number 19. How many ways can first, second, and third prize be awarded with a contest of 970 contestants? Well, there's 970 people who can get the first. Can't get first and second, so now there's 969. And then third is 968. Right, this would be a permutation because order is mattering. Getting first prize is not the same as getting second prize. So this is 970 P3 if you want to do that. There's a permutation button on your calculator. You could just multiply these three numbers together too. But there is a permutation button on your calculator. And if you go to the math menu again, math, go over to probability, choose permutation, which is number 2. And you can do 970 in the first thing and 3 and hit enter. And you should get 909852240. All right. All right, so in a lottery game, the machine has 48 balls marked with numbers 1 through 48, and 6 of them are taken out at random, right? So this is probably like this is probably the hardest one to visualize. All right, so we have 48 balls, 6 are taken out at random. I want you to think about, again, the player picks 6 of these numbers, trying to match 6 balls to come out of any machine in order. If exactly 4 of them of those 6 numbers match are drawn, if the player wins third prize, what's the probability of winning this prize? Getting 4 out of 6. All right, so just I like to think of this way. I have 6 winners. Right? That means I have 42 losers. All right. And I am going to pick 4 of these winners, which means because I'm picking 6 balls, I'm going to pick 2 losers. Okay. And I am looking for how this works. So I'm going to have 6 winners. I'm choosing 4 of them. Okay. Now this, again, if you don't know what this symbol means, please refer back to that PowerPoint video that I made about counting techniques. It's probably the most important video in this entire chapter, entire unit. So if you don't know what symbol, I am choosing 6 from 4. Now I have 42 losers. I'm going to choose 2 of those. Altogether, there are 48 balls, and we're choosing 6. want you to just take a notice of this pattern here. These two add up to here, and these two add up to here, right? So I can do this on my calculator, this 6 choose 4. You can also do it in Excel, and you can also do it in Minitab. Just Google combinations in Excel, calculating combinations in Excel, or calculating combinations in Minitab, and it will walk you through how to do it. On your calculator, you'll have a button that says like NCR, and almost lots of calculators have them, not just the super fancy graphing ones. A lot of calculators will have these buttons. But on the TIs, you would hit on math, go over to probability, choose number 3. So I went math, over to prob, I choose number 3, and then I hit enter, and then I put in the 6 and the 4, and hit enter, and that's 15, right? And then 42, choose 2, is 42, choose 2, is 861. And 48, choose 6, is this number right here. So I'm going to take this number times this number and divide it by this number. Okay? That's the probability that I would win this prize. All right. All right. So this is what we call a discrete probability table. Tells you all the probabilities for each option in that. All right. What's the probability x equals 6? Well, you can just look right here. There we go. And just put that number there. What's the probability there are 6? Um, Find the probability of 6 or fewer among the 12 zeros. 6 or fewer. Well, add these guys up. Now it's 6 or fewer. And then I'll let you kind of reason that one out yourself. Once you figure out what these probabilities are. Okay. A poll showed that 67% of Americans say that they believe that some people see the future in their dreams. What is the probability of randomly selecting someone who does not believe that see the future in their dreams? Report this as a percent. Right. Well, if you are somebody's, that's how many people believe it. So the people who don't believe it is just 100% minus that. So there you go. And you either believe it or you don't. And those are the only two choices. They add up to 100%. You can't kind of sort of believe it. Okay. And our last problem here is 23, and it is the same one that we did on number 5. All right. And I just slightly worded differently. This time they only get lower cases, so only 26 here, and numbers, and it's only 6 characters long. All right, so we're just going to take, and it's a probability, so we're going to take 36 ways, 6 possibilities. 36 to the 6 is how many different possibilities. We're going to get it on the very first try. There's only one try. That's going to be my answer. All right. Okay. So I'm just going to do this real quick. 1 divided by 36 raised to the 6th. And I would just add this in 4.5939 times, no time symbol, 10 caret negative 10. So that's how I would enter my answer, just like I said right here. But it's easier to just enter that in. So you can do that too. All right, and those were all of those answers. Please let me know if you have additional questions. And I'm sorry for the delay on this video. I hope you guys are all doing great. Thanks. Bye.